Hi, my name is Peter Brellett, and today we're going to be going over Charles's gas equation, as well as how to derive it from the ideal gas law equation. And then finally, we'll go over a real-world problem to help solidify how and when to use Charles's gas law. So, the gas law itself states that the volume of a gas is directly related to the temperature of that gas when there's no change in the pressure and amount of gas. And this could be mathematically defined as the equation V1 divided by T1 is equal to V2 divided by T2. And again, pressure is constant, and amount of gas, or N, is also constant. And this is Charles's gas law. So how do we derive this from the ideal gas law? Well, the ideal gas law itself states that pressure times volume divided by amount of gas times temperature is equal to the ideal gas constant, or rather R. And what we can do is we can set up two problems, one for gas 1, one for gas 2, and then we can go from there. So for starters, we can say that for gas 1, we have the equation P1 times V1 divided by N1 times T1 is equal to the ideal gas constant, R. For gas 2, we can say that P2 times V2 divided by N2 times T2 is equal to R. And because R is equal to R, we can combine those equations to get this. P1 times V1 divided by N1 times T1 equals P2 times V2 divided by N2 times T2. And because, again, in Charles's gas law, we're given the fact that pressure is constant and amount of gas, N, is also constant, we can simply cancel out those variables in the equation that we've created here, because again they're constant, meaning they don't really change, to get the final equation, which is V1 divided by T1 is equal to V2 divided by T2. And this is Charles's gas law, derived from the ideal gas law. So here is a real-world problem, and then we can solve it. So, helium gas is used to inflate large balloons at a carnival. A sample of helium gas has a volume of 7.57 liters and a temperature of 12 degrees Celsius. What is the final volume in liters of the gas after the temperature has been increased to 37 degrees Celsius, when the pressure and amount of gas do not change? So what do we know? We know that there's no change in pressure and there's no change in gas. And because we're given those qualities, we know that we can use Charles's gas law. So the variables that we do know is, again, we have to find T1, T2, V1, and V2. We're given that temperature 1 is equal to 12 degrees Celsius, and that temperature 2 is equal to 37 degrees Celsius. And because whenever we deal with gas equations, we always have to change whatever temperature we're given in Celsius or Fahrenheit and change it to Kelvin, because Kelvin has to do with the kinetic energy of a gas. So we add 273 to both sides, to both temperatures given, to get the final answer of 285 Kelvin and 310 Kelvin. Then finally, we're given volume 1 is equal to 7.57 liters. And V2 is the unknown variable, or X. So where do we go from there? Well, again, we simply fill in the equation for what we know and what we don't know. And we can always rearrange the equation so that we have V2 as the lone variable. So it would look something like this. V2 is equal to V1 times T1 divided by V1 times T2 divided by T1. And then we simply fill in the variable, or all the variables, with what we already know. And when we do so, we come out with the answer V2 is equal to 8.2 liters.